Good morning, ladies and gentlemen. Today we are on page 53 of your student journal, and we are going to get started on our problem of the day first. So today we're going to just refresh our minds about how to round, specifically using decimals. So the first number I'm going to give you is 5 and 25 hundredths. So this is 5 and 25 hundredths, and I want us to round it to the nearest tenth. So the first thing I would do is I would find the place value tenths. So this is the tenths place value, and that's where I want you to round it to. So what we did in 5th grade is we talked about this bossy neighbor on the right who always thinks he's right. So for this problem, my bossy neighbor on the right is the 5. And I always remember he thinks he's right, so he's on the right. So this bossy neighbor on the right says, I'm a 5, so you go up. Because if you remember when you were younger, you learned the 0 through 4 stays the same as before, 5 through 9 goes up the line. So he says, I'm a 5, so you go up. So this becomes a 3. Everything after it becomes a 0, and everything in front of it stays the same. Okay, let's do another one. So this one I have 7 and 199 thousandths. Okay, 7 and 199 thousandths. This time, the problem says round it to the nearest hundredth. So we need to underline the hundredths place value, which this is my tenths, so this is my hundredths. And my bossy neighbor on the right, who thinks he's right, is this 9. So this time, my bossy neighbor on the right says, I'm a 9, so you go up. Well, this one's a little tricky because when the 9 goes up, it goes up to a 10, which actually means then I have to add one over there. So kind of like carrying it over. So this one, the 9 became a 0 and I carried the 1. So this is 7.200, which is really tricky. Okay, the one I want you to do on your own is 10 and 487 thousandths. And I want you to round this to the nearest hundredth. All right. Okay, so you're going to be doing that on your own and letting your teacher know your answer. All right, I'm going to jump in and get started on our lesson today. So we are now going to be adding fractions with unlike denominators using an algorithm. Okay, so our goal today is, today I will add fractions using an algorithm. Okay, so we already added them using the area model. Now, the great thing about the area model is it's really easy to see why you get the answer you get. The bad thing about the area model is it takes a lot of time. It's not very efficient. Efficient means like a good use of your time. So it's not very efficient, especially if you had really large numbers. So sometimes the algorithm is called like some of your parents might call it the normal way or the standard way. I wouldn't call it the normal way, but I would say usually the algorithms are the most efficient ways. Okay, so let's look at our vocabulary before we get started. And it just first reminds us about a fraction that we have remember our numerator and our denominator. Then it says something we haven't seen yet called a common denominator. Fractions with the same denominator. I'm going to put a star there because actually when we're adding fractions, that's going to be really important. You can only add fractions when they have a common denominator. And then we've already talked about simplest form and how we do that. And we've talked a little bit about what reasonable means to have an answer that makes sense or is logical. Okay, so let's look at our steps. We're going to be using the steps they give us, but we're going to change them a tad bit. So our first step says find a common denominator by multiplying the denominators of the two fractions together. And then find new numerators by multiplying each of the numerators by the denominator of the other fraction. Okay, that's a little bit confusing. So we're going to cross that off and we're going to kind of rewrite that. Okay, we are going to say instead for step 1 that we need to have same denominators. We must have same denominators. So the way that we're going to be doing that is we are going to multiply by fractions equal to 1. And I'm going to explain what that means in a minute. So we need to have same denominators, and we're going to multiply by fractions equal to 1. Okay, so what does that look like? Well, fractions that are equal to 1 mean the numerator and the denominator are the same. So a fraction that's equal to 1 is 4/4. The reason it's equal to 1 is the denominator tells me it was cut into 4 slices, and the numerator tells me I have 4 slices. So it is the same as 1. And we could do that with any number. We could say 3/3. The denominator 3 tells me it was cut into 3 slices, and the numerator tells me I have 3 slices, which means I have 1 whole. So anytime you have a fraction where the numerator and the denominator are the same, it means it's worth 1. Okay, you also probably remember when you were younger and you learned your multiplication facts that when I multiply something by 1, I don't change its value. So 6 times 1 is 6. 8 times 1 is 8. You don't change its value. So that's what we're going to be doing in step 1, is we're going to be multiplying fractions by 1 to get same denominators. Okay, our next step says we're going to add the fractions. When you add fractions, you add numerator only. You never add the denominators. So numerator only. And then our next step is we're going to simplify. And remember, when we simplify, we use the GCF. Okay, so we don't have that many steps today. We're going to find same denominators, then we're going to add fractions, numerator only, and then we're going to simplify using our GCF. Okay, so I'm going to get started right away. If you want to set down your pencil and watch, here is my first problem. And my first problem says 1/2 plus 3/5. Okay, so I can't add these because to add fractions you have to have same denominators. Notice I don't have the same denominator. Okay, so I'm going to actually set my problem up vertically. It's going to be easier for me that way. Okay, now I need to make them have the same denominator. So what I'm going to do is, it said in my steps, I'm going to multiply by fractions equal to 1. Okay, so watch what I'm going to do. If I look at my denominators, I had a 2 and a 5. I'm going to multiply this fraction by 5/5. Now, here's the thing. I'm allowed to do this because 5/5 is the same as 1, so I'm not changing the value. The reason I chose 5/5 is because I used this denominator to help me. And watch what I get. 1 times 5 is 5. 2 times 5 is 10. So 1/2 is equal to 5/10. They just look different, but they're actually equal in value. Now, this fraction, I'm going to also multiply by a fraction that's equal to 1, but I'm going to multiply it by 2/2. Now, 2/2 is equal to 1, so I'm not changing 3/5 value. And the reason I chose 2 over 2 is I used this denominator. So I used the opposite denominators to help me. And watch why. 3 times 2 is 6. 5 times 2 is 10. Look what happens when I did that. I got my goal of having same denominators. That's what I wanted to happen. I wanted same denominators. And now I have them. So now I can go on to step 2 and it says add the fractions numerator only. So 5 plus 6 is 11 tenths. Okay. Now my next step says to simplify. Before I simplify, I noticed a problem. That's improper. Improper means, remember, a larger numerator than denominator. So if you remember a while back how to fix that, I can use that in and out strategy. And I can put my 10 outside and my 11 inside. So 10 can go into 11 once. 1 times 10 is 10. And I'm left with 1 and 1/10. Now, that is kind of a version of simplifying when you're making it go from improper to proper. But I still could maybe see if I could simplify this. One way I know I could never simplify this is I'm never going to simplify 1 smaller. So my answer is 1 and 1/10. Okay. Let's watch another one together and see how you feel about this after you see another one. Susie needs ribbon to make some bows. She has 1 and 5/6 yards of ribbon on one spool and 1 3/4 yards on another. How much ribbon does she have all together? Okay, so I know it's an addition problem. So let's look at our steps. Step 1 says we need same denominators. And we're going to multiply by fractions equal to 1. So let's set it up. I have 1 5/6 plus 1 3/4. Okay, so I'm going to use the opposite denominators to help me. So I'm going to multiply 5/6 by 4/4 because I use this denominator to help me. So I'm going to keep my whole number, and I have 5 times 4 is 20, 6 times 4 is 24. And again, 4/4 is equal to 1, so I didn't change the value, I just changed the way it looks. Okay, now for this one, I'm going to use the other denominator to help me. So it's a 6, so I'm going to multiply this one times 6 over 6, which is 1, and I get... my whole number stays the same. 3 times 6 is 18. 4 times 6 is 24. So I accomplished my goal of having same denominators. Okay, now my step is add the fractions numerator only. I should have probably added on their whole numbers also. So 20 plus 18 is 38 over 24. And then I have 1 plus 1 is 2. Okay, so I ended up again with an improper fraction. So again, 38 on top of 24, that's improper because my numerator is larger. So let's use that in and out strategy. This one's going to be a little bit tricky because 24 can go into 38 one time. And I get 8 minus 4 is 4. So I'm getting 1 and 14 over 24. Now the problem is though, is I already had a 2. So I can't forget that I already had a 2. So this is the value of this, but I already had a 2. So I really have 3 wholes and 14 over 24. Okay, now when I continue to simplify though, because that's only part of the simplifying. Remember, I'm going to do my table for my numerator. So let's come over here and do a table for 14. 1 times 14, 2 times 7, 3 times nothing, 4 times nothing, 5 times nothing, 6 times nothing, and 7 repeats. So my factors of my numerator are 1, 2, 7, and 14. So let's see which ones are the factors of 14, 2. 14 is not a factor of 24. 14 times 1 is 14, and 14 times 2 is 28. What about 7? 7 times anything equal 24? No. What about 2? Does 2 times anything? Yes. So my GCF is 2. So let's divide both by 2. And I'm getting 3, and 14 divided by 2 is 7. 24 divided... That was a lot of work for that one problem. My answer is 3 and 7/12. Okay, so notice when I did the simplifying step that I also had to correct improper fractions in that step. Okay, let's try some together. So we are on page 54. Here's our first problem. It says 5/6 plus 8/9. Okay, and our first step is to find common denominators by multiplying by fractions that are equal to 1. So let's set it up. 5/6 plus 8/9. Okay, so we're going to use opposite denominators. So this denominator is a 9, so let's multiply this one by 9/9, which is equal to 1. So 5 times 9 is 45. 6 times 9 is 54. Okay, and this fraction we're going to multiply by 6/6 because I use this other denominator to help me. So 8 times 6 is 48, and 9 times 6 is 54. Okay, so that is step 1. We accomplished getting our same denominators because you cannot add if they don't have same denominators. All right, now we're going to do our next step, which is add, and we're going to add the numerators only. So 45 plus 48, so 5 plus 8 is 13, and add my 1, so I'm getting 93/54. Definite improper fraction. So our next step is to simplify, but before we can simplify, we have to correct this improper fraction. So remember our in and out strategy. 54 can go into 93 only one time because 2 50s would be 100. So 1 times 54 is 54. And what do we get? 39? These are some really large numbers we're getting. Okay, wow. So let's do a factor table and see if we can simplify this. This is a big one. So 39, what do we know? 1 times 39. 2 times nothing. I know because 39 is an odd number. 3 times 13. 4 times nothing. 5 times nothing. 6 times nothing. 7 times nothing. 8 times nothing, 9 times nothing. Oh, are you seeing a pattern here? 10, nope. 11, no. 12, no. And 13's a repeat. Wow. So our only factors of 39 are 1 and 39 and 3 and 13. So we could see, now 39 I know does not fit into 54. But we could see 13. 13, that's probably a kind of a hard one to do in your head. So we could maybe check it and see what's 13 times 1 is 13. What is 2 13s? 2 13s would be 13 and 13 is 26. What's another 13? If we added that, 39. What's another 13? And if you needed to do some side work like I am, another is 52. So is 54 going to work? No. Which tells us that is already in simplest form. But sometimes when there are large numbers like that, you really have to take some time to double check that. Okay, let's try another problem. Our next one says, Don bought 3/4 of a pound of jelly beans and 5/8 of a pound of gumballs. How much candy did he buy in total? Okay, that tells us it's our addition problem. So remember, step one is we are going to set our problem up and find common denominators by multiplying by fractions equal to 1. Okay, so this denominator is 8, so let's multiply this by 8/8. And what do we get? We get 3 times 8 is 24/32 plus, okay, and because this denominator is 4, we're going to multiply this one by 4/4, and we get 20/32. So again, we met our goal of having common denominators. So our next step is add, but only the numerators, not the denominators. So 24 plus 20 is 44/32. Okay, and our final step is to simplify. But before we simplify, we have to correct this improper fraction. So what do we get? 32 can go into 44 one time. And we get 1 and 12/32. Okay, let's see if we can simplify that. Let's make a table for 12. 1 times 12, 2 times 6, 3 times 4, and we have a repeat. Okay, is 12 a factor of 32? 12 times 2 is 24, and 12 times 3 is 36, so I say no. Is 6 a factor? No, because 6 times 5 is 30, and 6 times 6 is 36. Is 4 a factor? Yes, because 4 times 8 is 32. So let's divide both by 4. And we get 1 and 3/8 is our final answer. Okay, ladies and gentlemen, I hope you're feeling a little bit confident. If not, remember you can keep watching the video as many times as you need to. Your job today is you're going to do page 55, 56, and 57. Have a nice afternoon.